Welcome to the answer to the honeybees problem that I set last week. Now remember, we had 3 types of bees. There were the queens that were very special, there was only one of them in every hive. And there are the worker bees that are the females. Now the females, they have 2 parents. They have a male and a female parent. And there are the drones, the male bees. Now the male bees, they come from unfertilized female eggs, so there is no male bee involved in that. Okay, so we have this kind of thing. Now I set you the challenge. If in the first generation we had 1 male, okay, so there's 1 in this generation, and that is just 1 male. I said, if we went back into the past, its second generation, that would just have a female in. There would just be 1 in there, and that would be 1 female. If we go back another generation, there would be a male and a female. So we would have 2 in this generation, 1 male and 1 female. Now, I asked you the challenge. In the first generation, we had 1. Second generation, 1. Third generation, we had 2. I asked you to find out how many there would be in the 10th generation and how many males and females, and try and see if you can work out why that is the case. Now, if we continue this, okay, we have a female here. We're going to have a male and a female here. So we're going to have 3 in this generation, 1 male and 2 females. In this generation, we're going to have a male here. We'll also have a male here, but every one of these will have a female parent. There's always a female parent. That's really important. Okay, so in this generation, we now have 5, which is made up of 2 males and 3 females. If we quickly do the next generation, then we're going to have a male parent here, a male parent here, a male parent here. So the number of males in the next generation is always the number of females in the previous generation. Okay, we're going to have a female here, a female there, a female there, female there, and a female there. Notice the number of females is the number in the previous generation. Okay, so altogether here we have 8, which is made up of 3 males and 1, 2, 3, 4, 5 females. So let's take a look at what we got so far here. Let's look at the numbers we've got. 1, 1, 2, 3, 5, 8. So the number in these goes 1, 1, 2, 3, 5, 8. Now those of you that did the task last week, my paving problem, may notice that this is exactly the same numbers that we had there. These numbers just seem to appear in mathematics for some reason. These are numbers on the Fibonacci sequence. So notice 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. So the next number would be 5 plus 8 is 13, 8 plus 13 is 21, 13 plus 21 is 34, and 21 plus 34 is 55. So this would be 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th generation. So in my 10th generation, I reckon we will have 55 bees altogether. How many males and females? Well, let's take a look at the number of males. We've got 1 male here. We've got no males here. We got 1 male, 2 males, 3 males. Now, this part here, 1, 1, 2, 3, that's the Fibonacci sequence again. So this will continue on here. But notice it doesn't start with 1, 1. It starts with 1, 0. Now, some people might argue that the Fibonacci sequence continues in the opposite direction here. It could start 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 2. So, if we continue this on, we have the 1st generation, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. So we will have 21 males. 21 males or drones. Okay, so if we look at the females now, we have no females in the 1st generation, then 1, 1, 2, 3, 5. So now we're starting here at this point. So we have 0, 1, 2, 3, 4th generation, 5th, 6th, 7th, 8th, 9th, 10th generation. So we will have 34 females, which are the workers. Okay, so after the 10th generation, we get this: 55 bees, 21 males, 34 females. Trying to work out why this is. If we look at this whole generation here, okay, every male and female, okay, you have the number of females is the number of in the previous generation. Okay, so we've got 1, 2, 3, 4, 5. That is that generation there. Okay, the number of males, 1, 2, 3, well, every male comes from a female, which is the number in the previous generation. So if we look, the 3 here goes up there and the 5 goes there. So that's why it is the previous 2 added together. Now, those of you that want to see some really impressive maths may like to look for a very special formula. And this is the formula to find out any number in the Fibonacci sequence. And it's quite a complex formula. Okay, it involves a lot of square roots involving 2. And it's 1 over root 5, then a big bracket with a little bracket inside here. And this is raised to the power n, what number term you're interested in. Take away 1 minus root 5 over 2 raised to the power n. And this will actually give you any number in that Fibonacci sequence starting at the 1 here. Okay, you may like to have a little look at that and see if you can find out the mathematician that formula is named after. It's not Fibonacci, but you can find it if you search for Fibonacci nth term. Okay, there'll be a new challenge next week for you to get looking at. Okay, thanks then.